Hello, I'm the power guy from TDK-Lambda. Today, we will discuss power supply life. Yes, power supplies do wear out, but they may not necessarily stop working completely. High electrolytic capacitor case temperatures will cause degradation, impacting the performance of the power supply, and we will cover aspects of this. During a short interruption to the AC input, the power supply should keep delivering power for several milliseconds. That energy is stored in the bulk capacitor. If that capacitor runs hot, the electrolyte will dry out, reducing the capacitance value. Less energy will be stored and the hold-up time reduced. Small AC interruptions will then cause the outage voltage to drop, causing a system reset. A similar situation may occur with the output capacitors. Remember, each 10 degrees Celsius rise in temperature reduces the capacitor life by 50%. Plus 30 degrees Celsius means its life could drop from 30,000 to 3,750 hours. That's just 22 weeks in continuous operation. If those capacitors are too hot and degrade, the output ripple will increase and load transients will cause the output voltage to drop significantly, again resetting the system or causing errors. Thermal testing must include small electrolytic capacitors, especially those by heat sinks or hot magnetics. These are critical to the power supply startup circuit when the AC is applied. A degraded capacitor issue will not manifest itself until a restart is required. Is MTBF an indication of power supply life? No, this is a common misconception. The MTBF number is the mean time between random successive failures after repair. The probability of survival is calculated using the formula e to the power of minus t divided by the MTBF number, t equals time. When t is the stated MTBF number, it assumes only 37% of the power supplies will still be operating, regardless of the MTBF number. Looking at it a different way, the 1.5 watt TDK-Lambda CC G1R5-12-05S DC-DC converter has a calculated Telcordia MTBF of 6,179,885 hours. That is 705 years. Determine the lifetime at 105 degrees Celsius of each capacitor from the manufacturer. If that is 5,000 hours, then at 85 degrees Celsius, the expected capacitor life will be 20,000 hours. Thermocouple each capacitor on the exposed metal top of the case. Install the power supply in your system and operate at the worst case condition, the lowest nominal input voltage, the highest ambient and the highest load. Allow temperatures to stabilize for at least 3 hours. 20,000 hours life could represent 10 years operating 8 hours a day, 50 weeks a year, or 2.5 years operating continuously. Measuring all the electrolytic capacitors in the power supply under the operating conditions for the end application is essential to estimate the life that can be expected from the power supply. Knowledge is power. Power is TDK-Lambda. Thank you.